Hello everyone, welcome back to the session. This is Gyanendra and we are here in another live lecture in the series of your IT JEE preparation. Hope you're all healthy and are doing good. So with that known, welcome back to this session for all of you and hoping that your practice and your preparation are going really well and you guys are now trying to solve the problems as you would have already understood the concept to a certain level. You would try to solve the problems too of those topics that you have covered up, right? Okay. So again, welcome back. And yeah, as we already have been doing the alcohols chapter, we did start it and we did talk about a lot of things regarding the alcohol. But alcohol is a big chapter. Hello, Aditya. Welcome to the session. So as I was talking about this alcohol chapters is different type of things, and this is the first chapter where you'd use a lot of mechanisms, like you'd use all the substitution mechanisms. You may also use the elimination mechanisms. Plus all these four types of substitution that I've taught you could come handy there. Okay. So with that note, let us not delay any further and dwell into the topic. Today, what we will be talking about is about the reactions shown by alcohol. We may also soon be covering up the diols and other things that are important for ITJ, but today we'll be focusing on the reactions, many of which you already have an idea. But yeah, I'll tell you things that could actually help you in order to understand the things or the things that you're preparing for, the exam that you're preparing for. Okay, then. So let us start with knowing me. I'm Gyanendra and I've been teaching in around different places for around 7 years. So I know about the things that you have to learn. Okay. Yeah. Too much of this and that we have talked or we could have talked, but yeah, what is important is just the subject, and let's directly and only talk about the subject. Yeah, if this, we have understood how do you get an alcohol. You all know this alcohol would have this simple bonding, right? R going to be bonded with O and H. This kind of bonding where you have this partial charge distributions would actually be an alcohol molecule, right? This is how you actually get up an alcohol molecule. But now you just imagine you have an alcohol. Since I've already told you that there is this partial positive and negative charge distribution in this manner, when this bond has to get cleaved, how this bond or this charge species do help us in order to understand what would actually happen, how the things would happen over here, right? So those things can be understood by understanding this. So let us not delay and let us directly try to understand this, what happens, how it happens, what kind of reaction would it show. Now just imagine, if there is this type of bond, the cleavage of that bond would only result in the outcome, and that outcome is the one which would tell you what would be the product of the reaction, right? So we would need to understand how is this charge distributed and what would happen when this charge distribution would result in complete exchange of electrons, right? So just imagine if this bond is getting cleaved from this direction. As you already can see, there are two places where this opposite charges are present, and both of these places can get cleaved, children. And with them being cleaved, the electron density would shift accordingly, right? So let us just imagine that the bond cleavage occurs in this manner, right? If it is occurring in this manner, what happens? What happens here is this electron pair would move towards that atom which is more electronegative, and that is this oxygen atom. When this electron pair would move towards the oxygen atom, all the electron density would shift over there, and what would get generated? What we would get generated is simply this RO minus plus an H plus ion. So what kind of behavior what kind of behavior is this species showing over here? You could clearly understand just by having a look at it. Since it is losing an H plus ion, and you could also understand by looking at it that hydrogen is attached over an electronegative atom. What does that mean? That means that H plus is being given out, or the substance is acting as an acid, right? So that behavior would show the reaction of alcohols as acids. Okay, children, hope you've got the idea of that, right? So let us look at what would happen if ROH is being broken from another place, right? You just understood first is the place where O and H bond is being cleaved. H plus comes out, O minus gets created. Okay, so actually the reaction would be shown majorly because, I mean, mostly because of this thing. H plus would be not such in a higher amount that you could understand or look at it as its acidic nature has acted a lot. This RO minus would be the more active thing there. Okay. Now the next bond that can get cleaved is between R and O that I've already told you. There are two places where opposite charged polarities are there. So when the bond gets cleaved, there's two other regions that would be causing the bond to be cleaving in this manner. Okay. So when this bond gets cleaved again, which atom is more electronegative? Is it oxygen or is it that alkyl group? All of us know it is definitely the oxygen atom that is more electronegative. And which atom has a partial positive character? R group. So when this bond is about to get cleaved, or when this bond would get cleaved, oxygen would take up both the electrons and would become negative. And what is it actually giving you, children? Well, let us just look at it. When this bond breaks in this manner, what it ends up giving is OH with an extra pair of electron, and that would result it or make it to be a negative ion, right? So that is what you need to be remembering, that OH minus would get created. But because electron is being removed from alkyl group, what charge do you expect this alkyl group to have? Definitely a positive charge, right? So R plus will be created. Now actions that this would show, like if you look at this one over here, RO minus, when if you look at it, it would act as a nucleophile, right? So what would it do? It would show substitution reaction. It would show elimination, could show also an elimination reaction, right? So this is how you could approach and understand what could they give if this kind of condition works out. Substitution could work out, elimination can work out, right? These are the types of reaction that they could give. Now here, because carbocation is generated, they can't attack any other species. Instead, they would get attacked by the nucleophiles. What they actually are, they are simply electrophiles. Because they are electrophile themselves, or this carbocation is an electrophile, it would seek a center that has a lot of electron density. Why would it seek that? Because it wants the electron to be taken up, as it would lack electron density. Actually, that is what the positive charge mean, right? It lacks electron density. So what it does is it simply gains this electron density, and by gaining the electron density, it is going to become stable. So that is the catch, children, that you are supposed to remember and understand. Hope you've got the idea of what happens. So the third part is where ROH itself completely makes an attack. Okay, even that kind of reaction does seem to work out. Although the attack happens by this O group of ROH, but then that whole, as a whole also, it could work or would react. We'll see all these reactions not one by one, but then yeah, as part of their importance or in the way they have been used up much. So hope this part is clear and you've got the idea of how and what to be done here. Let's move further. Sorry. Now, depending upon which bond is getting cleaved, the order of reactivity varies, children. For example, if you'd see RCH2OH, okay, if this bond is being cleaved, you know, what it would end up giving you is simply RCH2O minus, okay. I'll just draw it in black color so that it is more visible. It would give you RCH2 and O minus. If you look at this molecule, it would try to attack. I mean, just imagine there is this negative charge that is being created. Now, do you think a negative charge is more stable over tertiary one, or would it be more stable over the primary one? Everybody, hello, hello. So what happens over here is this negative charge would make would be more stable over a species that has less electron density, or that has less electron density. Yeah, you all know tertiary one is going to have more electron density than the primary one. So you can clearly understand that the tertiary one isn't going to be as stable as of that of the primary one, right? Okay. So this is it. This is the catch here, children. Let us move further and look at what would happen if the bond between C and O gets cleaved instead of this OH. If this bond gets cleaved, what happens? what happens is you end up getting a carbocation generated, if you remember, RCH2 plus. You tell me what kind of carbocation is going to be more stable. A primary carbocation is going to be more stable, a secondary one is going to be more stable, or is it the tertiary one that is going to be the most stable, children? I mean, there wouldn't be anybody who doesn't know that. The tertiary one definitely is going to be more stable, as that is going to have more amount of charge. I mean, that is going to have more amount of stabilizing groups, right? The tertiary one is going to be favored. That's why this one. So hope that point made it clear to you. And also for the reactivity, the bond cleavage should be easy. So if the bond breaks easily, the reaction occurs even more faster. Okay. That is the catch that you are supposed to know. And with that, yeah, different types of reactions of alcohols can come up. We could see the oxidation reactions. Okay, we'd see how primary and secondary on oxidation gives you aldehydes and ketone. We'd also observe for having oxidation, you're supposed to have a hydrogen over the secondary, I mean, over this position where oxidation occurs. But if there is no hydrogen at all, there wouldn't be no oxidation. Okay. Now remember that aldehyde, because it has CHO group over the terminal, it can further get oxidized to carboxylic acid. So what it end up giving you is RCOH. But the same thing isn't going to work out well for ketone. The reason being, you cannot just like that oxidize a ketone. The ketone molecule has already oxidized to a good form, right? In order to oxidize that further, you're supposed to break that carbon-carbon linkage, children. And that would only happen at extreme condition with specific reagents. Okay. Then the next reactions are the ones that we have already talked about, the dehydration reaction, removal of water. So in these reactions, water is going to get released. And how do you think water gets released? In the presence of acid. OH minus attacks on H plus, and that's how the acid gets released. I'm not just blabbering, I'll be showing you that as well in some time. The last reaction, that is going to be the esterification reaction, not just the last reaction of single monohydroxy groups I'm talking about. Then there's this diol, which could show even more number of reactions. Okay. So yeah, there's this esterification. This esterification reaction has been there for long. When you guys might have heard like the process of making soap and other processes, right? This esterification is one of the very, very important steps in the preparation of soap. Actually, this is the major course, how the soap gets prepared, or the reverse of that is the major course, how the soap could be prepared. Okay. We'll not talk about the soap preparation now though, but yeah, will soon be. Now, depending upon the types of reagent you have, you may have an elimination reaction or substitution reaction in alcohol or in the preparation of alcohol. I'll just show you that again. Okay, what is this whole thing and why such a long number of things or options do you have here? Okay, just observe that you have CH2, CH2Br, okay, and you take up another CH3 over here, remove a hydrogen. 1, 2, 3, 4. Yeah, let us just say that you have a leaving group and you are supposed to react it with OH minus. OH minus has multiple options here, children. One easy option that OH minus can show is it could make an attack over here and Br can leave, right? So this is simple reaction which is called a substitution reaction. Then there is another possibility. And what is that possibility? Remember, with the same reagent there is another possibility. Okay, depending upon the conditions, suitable product gets formed. But yeah, with the same reagent itself, it could give you different number of products. We'll just observe how does it work out. Okay. So this OH minus over here would make an attack over this H plus, and by doing that, you would get a double bond created over here. The Br again leaves. Okay, so that single bond between the carbon and carbon tends to get converted to double bond. And what reaction would that green color be showing? Elimination. So basically, two types of reactions are going to be there. One is elimination. Okay, you guys know what happens and where would elimination gets favored. I'll talk about it in detail. Okay, the other one, children, is this substitution reaction. You know how different are they and what are the outcomes of substitution and elimination? How are they different from each other as well? Substitution. So in the case of substitution reaction, you would end up getting OH in the ring. In the case of elimination, you'd get an alkene. Here alcohol would get generated, here alkene would get generated. Okay. Now, in case elimination needs to occur, there are certain requirements. I'll talk about that as well. I mean, already you could see a lot of things over here, but understanding this big diagram might become a little confusing. I'll just help you out with this. I'll just write down the substitution or the factors that helps us identify that it would undergo substitution over here and elimination over the other side. Substitution reaction. Substitution and elimination. Now, in case of substitution reaction, hello Akanksha, welcome to the session. What happens in substitution reaction is simple. I already told you, like OH minus goes and substitutes it, right? So you have got an idea that what happens in substitution. In substitution, OH takes up the place of Br, but in elimination, OH takes out the hydrogen and takes out this Br and ends up giving you an alkene. So these two things are like very important, and I think almost all of you would be having a knowledge of it, right children? Hoping that knowledge is there, we would move further to the next stage. That is, what are the other factors that promotes substitution? How are you going to be sure that, yeah, that compound that is given to you would undergo substitution? First thing is look at the nucleophile, I mean, or a base. Substitution gets favored only by a nucleophile. I mean, if you have a nucleophile, then it would undergo substitution. If it is a base, then it would undergo elimination. But sir, how do I know? Because OH minus can act both as a base as well as a nucleophile. But then how am I going to be sure that the given OH minus would work as a base and not as a nucleophile? To understand that, children, what you are supposed to see or check out is the medium. Okay, guys? So if you check out the medium, you can clearly understand, yes, that this is what is happening or what would act. Hello, guys. Hope you are able to understand whatever I'm talking about. If you're getting a doubt, do let me know in the chat box and keep on responding so that I could understand that you are all there. Okay, Akanksha and rest of the people, Aditya. Okay. So what would happen over here is, in case of a nucleophile, the medium need to be something like water. You could have an aqueous medium like H2O. And in case of a base, the medium is mostly a basic medium. For example, you may have alcohol, you may have CH3OH or C2H5OH, or you may also have ammonia, something like this, that could promote a base. I mean, the action of a base would be observed naturally. Okay, so this is one of the things that would help you understand, would the given reagent be acting as a nucleophile or it would be acting as a substrate? Hope I'm clearly understandable. This is the first point that you are supposed to remember. The next point is temperature. As I already told you that high temperature favors elimination. The reason being, at high temperature entropy increases, and you know elimination would have a higher entropy, and thermodynamically that is what would be favored, and we know at high temperature, because of this region, elimination gets favored. But then on the normal ones, or the room temperature or general temperature, the substitution occurs. So this is one other way with which you could understand about how and what would be favored. Now the next thing, if you look at the type of a nucleophile, let's say if the nucleophile is bulky, children, you just imagine there was this heavy guy, and this heavy guy, just look at this thing. 3 people are sitting in a bench. Okay, there's this bench, and 3 people are sitting in a bench. Okay. Now one person wants to go there and sit with them. I mean, go there and be with them. There are 2 options that this third person has. One is the third person wants to go there and sit with them. The other option is it would just grab the food or something from them and run away. Now, which one do you think would be easier for this third person if there is this heavy people and they don't want to move? This guy can simply grab whatever they have and run away, right? That would be much more easier rather than going and sitting, because if he's trying to sit there, he would need to make up space for himself, right? That would take up a lot of effort. What happens there is called a steric hindrance. The bases, because they just have to grab a proton from the terminal position, they feel less hindrance. Well, the nucleophile, I've already taught you, when they want to be acting as a nucleophile, they have to go and give the electron pair and stay there. For that reason, it is going to be difficult with substitution if you have a bulky group. Okay, so if you have a bulky nucleophile or a base, the reagent, if the reagent is bulky, okay, if the reagent is bulky, it mostly would act as a base and would abstract hydrogen not from the center but from the terminal. Okay. On the other hand, here it would be slender or a smaller reagent that could act as what? As the substitution, as a nucleophile. So this point, that the kind of reagent you have, its size may decide would it act as a nucleophile and go and get attached there, or would it act as a base, depending upon what can it go and stay there. Bulky bases can't go and stay there, right? Instead it grabs the proton and runs away. That's much more easier. So that is the catch here, children, and things gets repeated. If you're observing, things gets repeated in organic. And if you understand one, it could be easily helped you. I mean, it would be helping you to understand the other things as well. So that point can be kept in mind while doing or while working on anything that you do. So this is what is the other thing that you're supposed to remember. That small reagent again favors it. Okay. Now that is one catch. Now what else is there that could help you understand that, okay, yeah, this is the mechanism that would get followed. Mostly this could help you almost in all the cases in identifying the kind of thing that you have. A reagent is done, but then yeah, in case the substrate, now there may be cases that even the substrate could decide, right? If the substrate is bulky, having elimination would be easy. If the substrate is light, having a substitution can also be easy. So depending upon the substrate, even reagent, small reagent or substrate, both of them are going to have a similar action. So that point should be kept in mind again. Hope you've got this idea. Let us now move and try to understand specifically in substitution and elimination reactions. Also, you have types. In substitution itself, you have 4 different types. In elimination, you have 3 different types. Out of the 3, 2 are important, right? The third one follows one of those that have already been taught. So you already have an idea which one is what and when would that happen. If you missed that, you could find that in the description below, because it has already been uploaded in the chapters where we did discuss about the mechanism. Most probably we had discussed it in the alkyl halide chapter, not most probably, we had discussed it in the alkyl halide chapter, for which you can find the links in the description below. So go check that out, and yeah, do like, share, subscribe, and let your friends know as well about it. Okay, then let us move to the next reaction. The next common reactions that alcohols show is the reaction with sodium. Now, sodium is an active metal. Okay, sodium tries to lose its electron. And when it loses its electron, you know, what happens is this electron will be taken up by a substance to become stable, right? So what ends up happening here is the sodium forms Na plus ion, and this alcohol, which this oxygen is negative, and once it loses the hydrogen with another alcohol, it tends to give you a hydrogen, and O minus gets attracted to this Na. So this is what would happen over here that you could understand and you could get easily. Okay. So what has happened over in the reaction of ethanol and sodium, not just sodium, even with potassium and some reactive metals, it does form alkoxide. Now, what is this alkoxide? Alkane, and then this oxygen with minus ion on that, minus charge on that, is called as an alkoxide, or alkoxide here. For example, here it is called as an ethoxide, and because sodium is attached, it will be called as sodium ethoxide. If potassium would have been attached, potassium ethoxide would have been the name. So that is the catch that you are supposed to remember, children. Now here, if anybody would ask you what is the order of reactivity, again, negative charge stability is more over the primary or even smaller, but then positive charge would be the other case around it. This is that one where you get a negative charge, that OH bond gets broken. Okay, so this is the way that this thing acts. Now the next reaction, children, is oxidation reaction. And in oxidation reaction, really a lot of thing happens. What happens? I'll just show you that. Okay, I'll first show you and then we'll look at this reagents and other things. Oxidation reaction can happen for primary, secondary, and tertiary in different manner. Let's say you have primary alcohol, CH3, CH2OH. Okay, this is a primary alcohol, and you are supposed to oxidize it. Now, when you're trying to take an oxidizing, I mean, obviously, if you're trying to oxidize something, you're supposed to use one thing, and anybody can tell what is it that we would use in order to oxidize something. We'd use an oxidizing agent, right? So what we do is we'd use an oxidizing agent. Just a second, and let us say we have used an oxidizing agent. We'll talk about the oxidizing agent and differences in the types of oxidizing agent and their action. If you have taken an oxidizing agent, what it would do is it would oxidize an alcohol. Initially, it would oxidize it to CH3, now this would change into CHO, that is an aldehyde. It would tend to give you an aldehyde, particularly for primary alcohol, aldehyde. Okay, we have got a question. Ekta, hello Ekta, welcome to the session. So, okay. Children, that understand one thing, that we have different things in different topics, but currently our focus is on IIT JEE, and we would definitely be bringing you whatever you would need. I mean, if you have anything like something in particular chapter, we could talk about that. And yeah, if there is anything that you would have missed in this chemistry of whichever chapter or class you have, you would ask particularly that. For me to teach you the whole 10th level chemistry, it would take a whole different course, right, Ekta? We'd think of bringing that as well. Okay, not an issue. But yeah, for now, our current focus is for IIT JEE. If you have anything troubling you in chemistry or whichever class you have it for, you could let me know here itself. I'd help you for that as well. Okay, but yeah, for the whole chapter to be taught or the whole subject to be taught, it may need some time for the people to bring a whole course for it. But yeah, I'll talk to the people and decide that as well. Anyway, so what has happened over here is this final O group, OH group, has been oxidized to aldehyde. Now with this thing getting oxidized to aldehyde, you'd again oxidize it further because there is a possibility of oxidizing. Even if you are in 10th grade, you would have seen this oxidation reaction very often, right? What is oxidation, if anybody would ask you? It is simply addition of oxygen, increase in oxidation state, removal of electron. These are the ways, children, in which you could understand that the reaction is undergoing oxidation. So once this undergoes oxidation, which it can even further, it would end up giving you RCH3COOH, or this CH3COOH. So this is the point, children, that you have to be understanding. Now I hope that you have got it and you have understood this idea. Now what it has made is carboxylic acid. So it has given you a carboxylic acid. That is the catch that you had to understand. Now, what is this oxidizing agent that could be used? Like, can we use any oxidizing agent to do this? Or is there a specific set? We'll talk about it, but first let's see. Next is the possibility of a secondary alcohol. Now let us say you have an alcohol like this, and this is supposed to get oxidized. When you take an oxidizing agent, you know what happens here, children? When you take an oxidizing agent over here, it gets oxidized. But this time it wouldn't give you a terminal CO group. Instead, what would it give you is a CO group over here. Now this CO group, if you try to oxidize further with an oxidizing agent under normal condition, you know what is going to happen? Nothing is going to happen. This isn't going to get oxidized even further. So that is the problem that you are supposed to remember, that you can't oxidize it further just like that. Yeah, there are conditions and temperatures and pressure where it does happen, but there the carbon-carbon bond breaks. So what happens here is, this is what happens in case of secondary alcohol. Now, if you take the tertiary alcohol, children, now if you try for secondary, primary, we'd obviously be trying even for the tertiary ones, right? So when you try to do the same thing with a tertiary alcohol, you know, if you take this oxidizing agent, nothing would happen. So you cannot oxidize a tertiary alcohol. That would be, I mean, to oxidize, you need to have a hydrogen present on the carbon having OH. I'll tell you what I mean. Over here, over the previous two places, you have a hydrogen over here, you have a hydrogen over here, you have hydrogen atoms present. If you don't have this hydrogen atoms present, you can't oxidize this alcohol. So that is the catcher. In the third case, you are not having that oxygen. So what are the possible oxidizing agents that you could take? There are different types of oxidizing agents that we can take. These are those oxidizing agents. Some oxidizing agent works in the aqueous medium, some are just needed to be in anhydrous state. You know, anhydrous literally means without water. Aqueous means adding water could also be helping. So there is this chromic acid, which is a general one, chromate salt. These two are very commonly used. And then there is this dichromate. Many people would have already heard about it. Then KMNO4, everybody had seen this O4. Literally means it is a very good oxidizing agent. Almost all of this oxidizing agent, if you observe them, they have a lot of oxygen atom. Right? So one way of understanding that this substance is an oxidizing agent is by looking if it has a lot of oxygen or not. One way. But yeah, there can be species that doesn't have an oxygen and can act as an oxidizing agent. For example, you just imagine that let's say you have Fe3 plus children. Now Fe's highest oxidation state is +3, and if it is at its +3 oxidation state, the only thing that it would undergo is to get reduced to either Fe2 plus or to be Fe0. So it would need to undergo reduction itself. If it would undergo reduction, what would it do to others? It would oxidize them. So it would be an oxidizing agent. That is the catch that you are supposed to remember, children. Hope you've got an idea of what is an oxidizing agent and what is a reducing agent, right? Okay, then now there are different substances. There is something called as pyridinium chlorochromate. Now, what is this pyridinium chlorochromate? It is just a combination of pyridine, HCl, and chromate salt. So, I mean, this chromate. So, if you write a pyridine, I mean, I'll just do it over here. You can just look over here. There's this pyridine, and with this HCl, you know what happens is N would take up the hydrogen. And this hydrogen that you're seeing over here is this hydrogen that has come from HCl, which was initially as HCl. Then after getting separated, after this H being taken out, Cl minus would get stabilized by the CrO3. Okay, so that is what would happen. Like this whole thing is called as pyridinium chlorochromate, a chromate having this chlorine group attached. It is a good oxidizing agent, and specifically it oxidizes things to a particular level. As I told you, some oxidizing agent can directly convert. When we have not told you, I'll tell you now soon. Now that some oxidizing agent can directly convert alcohol to carboxylic acid, skipping that alcohol part, aldehyde part. I'm talking about primary alcohols. But there are some oxidizing agents that for primary alcohol also, even if you use them, it could only bring it to aldehyde form. Now, no matter what reagent you take, in case of secondary alcohol, it would almost always give you a ketone, except for KMNO4, which under extreme condition can also give you different things. But in normal conditions, all the oxidizing agents with secondary alcohol gives you ketone. Okay, when the ones that are capable. On the other case, for primary alcohols, two possibilities arise. One are those reagents, those oxidizing agents that can only convert them to aldehydes. And second are those that can directly convert them from alcohol to carboxylic acids. The one that converts them from alcohol to carboxylic acids are strong, other ones are weak. So you could specifically check out and find out which ones are weak and which ones are strong, and which ones are capable of converting them to aldehyde and which ones are capable of converting them to ketone, carboxylic acid. So if you take a primary alcohol, KMNO4, H2Cr2O4, H2CrO4, okay, these are the ones that would convert them to a carboxylic acid. On the other hand, pyridinium chlorochromate, Swan's reagent, DMP, they tend to convert them only to aldehyde. They are weak oxidizing agent, children. Okay, so this is what you need to understand, and this is what you should be using. Hope you've got the idea that would help you understand what and how this thing works out. The next thing is in case of secondary alcohol. As I already told you, you take weak oxidizing agent or strong oxidizing agent. Even the strong ones aren't going to be able to oxidize this this alcohol to such a level that they would give you a carboxylic acid. Okay, children. So that catch is also needed to be kept in the mind while you are trying to do that. Tertiary alcohols, no matter what you do, it isn't going to get oxidized. That point is also needed. Okay. So let us move further to the next thing. Yeah. The next thing, children, is esterification reaction. In esterification, what happens is was this simple thing. You need to have a carboxylic acid and an alcohol. And that's how the reaction happens in the presence of an acid. How does it work out? It works out in a very simple mechanism that you just now see. In this case, this carboxylic acid would have this oxygen attacking over the H plus. Where does this H plus come from? You have this ROH, right, alcohol, and there's this H2SO4, some sort of acid that has this H plus. The first attack would happen from this O to H plus, causing what to be prepared? Causing this thing to be prepared. ROH H plus to be prepared. Now, this molecule is the one which is written over here. Now, this electron pair of oxygen would again make an attack on this H plus, form something like this. And this molecule, since it has a carbon which is partially positive, and this oxygen has a positive charge, plus that is an oxygen which needs electron density. So what happens next is this ROH would make an attack over here, causing the electron pair to be moving to this oxygen and neutralizing it. And what you would end up getting is something like this. There would be two OH groups over the R. But do you think that is stable? No, right? For that reason, this alcohol, the other alcohol molecules, takes up this oxygen and forms three of these OR or OH groups to be there over the carbon. But you know, that is not stable. I'll just do it so that it becomes easier for you to understand. I'll draw it myself or make an easier way for you to understand, children. So in simple terms, what happens over here is this, that this O from here makes an attack on this and this goes out. So in simple terms, what is happening is this RC double bond O, and let's just draw this. Okay, yeah, let's just keep it as it is. OH, and you have this ROH. I'll make this O and H in blue color, O and H, or green color, let's say. O and H. So you know what is going to happen here is simple, children. This molecule would make an attack over here. Once it has made an attack, the outcome eventually, initially would this O minus be formed. Once this O minus has formed, it would come back, and when it would come back, children, what would happen is this group would leave. Right? So this is what would happen, and that would result in the formation of something like this. RC double bond O R and H, and there would be a positive charge, plus OH minus would be going out, right? And what would this OH minus do? You all know OH minus can't do much other than taking out that hydrogen from here. So it would abstract this hydrogen, guys, and would let or would make this oxygen being neutralized. Hope you're getting the idea. It's like this. You have a carboxylic acid, you have an alcohol, they are getting merged. And what is coming out of it? Water is coming out of it. Why is it coming out of it? Because you want to make them stable. The substance themselves wants to be stable. So this hydrogen is going to be taken out. And once that gets taken out, what would be the outcome? And the outcome would be our answer. We end up getting an ester. So it gives you RC double bond OR. Now observe one thing, that which oxygen has come in. Is it the oxygen that was there with carboxylic acid, or was this the oxygen that was there with alcohol? And you're supposed to remember which oxygen will come in this ester. It is that oxygen which was there with alcohol, not the carboxylic acid. But then where did the carboxylic acid's oxygen go? It has gone out as water. They've shown it with the blue color, right? The reason why they had shown it in this color is because they want you to be identifying it, and that this is it that is being formed. That is the catch that you are supposed to remember. Hope that is clear. Let us move further. Yeah. The next reaction is the reaction with halo acids. Like halo acids are those acids that have halogen attached to hydrogen. So what happens in this case is this OH makes an attack over this halogen, cause this this water molecule to form over alcohol. It would form R, O, H, and a plus. So you know OH or O with a positive charge is unstable at all. This bond would try to get cleaved at all. It's like you have given, you have taken out money from somebody who's really, really greedy. You could just think about them, like how unhappy they would be, right? I've already been telling you this. So in that case, what happens is it wants to get broken, and you know this, broken and become stable. So this X minus does help it in doing that and provides its electron density to R and makes the bond moves. So what would be the outcome? The outcome is simple. This R and X gets attached and H2O comes out. This is a reaction where halogen gets attached and alcohol gets out, or water gets out actually. So it is called as dehydration for this reason, because water completely comes out. And the kind of pathway that it follows is this SN2 pathway, as I've already taught you earlier, which you know really well. Okay. Now, depending upon the kind of alcohol, if it is primary, it would happen differently. If it is secondary, it would happen differently. If it is tertiary, it would happen differently, right? So if you'd observe over here, this is a tertiary alcohol. And a tertiary alcohol would prefer having a carbocation formed, right? And then having the Cl coming in would become a little difficult. But yeah, that could also happen. Okay. So if you're looking at this halogenation, yes, it would come in. But yeah, there is one more possibility here. As if you'd see, if you get a positive charge, the Cl could even take out this hydrogen and form a double bond here. So it ends up giving you a byproduct that is an alkene children. So you are supposed to know that too. Other examples are also given for your understanding. Do check that out and see if you're getting it. Okay. Next reaction is for secondary alcohol. We had learned what happens in secondary alcohol. Again, OH2 forms and then elimination reaction or substitution reaction favors. Accordingly, the product gets formed. So here, I'll just show you what happens. Let us just say you have this molecule and there is a carbocation generated here. You guys know, would this carbocation be more stable in a secondary position, or there is this tertiary position next to it? Obviously, it is going to be more stable over the tertiary position. For that reason, there's a hydride shift occur, children. With this hydride shift occurring over here, you will get a positive charge developed over here and hydrogen here. Now the Br minus has only one option, which is more stable, not only one, but yeah, a more stable option of this being substituted here. For that reason, you could just observe the Br has come in this place. That is the catch, and hope you have understood that. Let us just move further to the next one. Hope you're getting the idea and you're understanding the things, children. Do let me know if you're finding any difficulty. Let me know in the chat box. Do let me know what is it that you are thinking about, or what is it that you have already learned. If you have got the idea of this topic earlier, also you have seen it, do tell me about them. Okay, the more you talk to me, the more I understand you, and the more I'll be able to help you. So hoping that you'll be doing that too, we'll move forward. The next reaction are those reactions where we use SNI mechanism. If you remember SOCl2, you could just observe the same way PX3, children. These molecules are those molecules that does follow the same mechanism. Okay, PX3, PX5, S, they have empty orbital, or even if they don't have empty orbital, that would get created by making an approach. But yeah, all of them has empty d orbital. It's not an issue. All in the sense this ones. And the kind of mechanism that they show is the one that we have already learned. Could anybody tell me what does this SNI stand for? This I literally means internal. So our reaction, a nucleophilic substitution reaction via internal nucleophile making an impact, is called as SNI mechanism. We had seen that in this process, Cl comes in, and in case of SOCl2, it would make up an attachment over the position that it gives you a retention in case of optically active compound. And in the presence of pyridine, what happens? That retention converts to inversion of product. So these things are small things, but yeah, do remember that, which we have already discussed. If you have missed those lectures where we did discuss about this mechanism, do check it out in the description box below. In alkyl halide chapters, we did talk about. The next reaction is dehydration reaction, which is simply removal of water. As we already have discussed this, what happens is this O attacks the H plus. After attacking the H plus, what it is going to get formed is OH plus. And that would result in this being broken down and hydrogen being released from here. And that hydrogen being released and this being released causes a double bond to be formed. So this is what happens, children, because of which the molecule ends up or tends to give you an alkene. Hope that is also clear. And yeah, different mechanisms are there about which we have discussed, right? So do let me know if you have a doubt. We'll talk about that. The next reaction of alcohol is also considered to be a test for primary, secondary, and tertiary alcohol. What you do is you do react them with something called as Lucas reagent. This Lucas reagent is something called as ZnCl2 in the presence of HCl. ZnCl2 in the presence of HCl would give you, is called as Lucas reagent. Now, if you observe these three things, when the Lucas reagent reacts with primary alcohol, the reaction happens really slow and you would not see any turbidity, any disturbance in the liquid created. But when you react the same Lucas reagent with tertiary alcohol, you know what happens? The reaction occurs really fast and you'd see a lot of turbidity. It occurs instantly. Okay, with tertiary alcohol, it occurs instantly. They've already written here. Immediately, turbidity gets generated. So what is turbidity? Like that agitation, that color itself can be understood to be the turbidity. Secondary alcohol would react with them, but a little slowly and would take up at least around 5 minutes. Primary alcohol won't even react under the room temperature. So you would need to put extra effort, maybe by heating it or by making it stirred up well so that they do get reacted, but it would take up a long time to happen. So with this, people identify, which one is it that is going to be the test that is going to come out to be a positive or a negative result. So that known, I hope you've got the idea. Let us move to the next one and try to understand some questions based on whatever we have talked about so far. So this question is, which alkene is most reactive in acid catalyzed hydration? Which alkene is most reactive in acid catalyzed hydration? Now we know acid catalyzed hydration would result in H plus being attacked. Now which one would make an attack on H plus first? Let us just say the last one does or this one does. If the last two does, when this one does, the above one, second last one, it would give you a carbocation next to a benzene ring. You would get a hydrogen over here and a carbocation. You actually have resonance. Now, if you look at the last one, children, what it would give you is something similar to that, I believe, but with extra stability. It is because of a carbocation and a hyperconjugation. So here you not just have resonance, you also have hyperconjugation, right? So hyperconjugation plus resonance, two things are there. Over here, just resonance is present. And in this case, you would not have resonance. You just have a carbocation generated over here. In the first case, you just have more hyperconjugation. Okay. So you could clearly see the last one seems to have multiple possibilities, and I hope that is going to be the answer. I hope you've got the idea. Why is that the catch? And why is that the reason for this to be the answer? Hope you would be able to do it and get to an answer using this, right? Let's just check that out as well. Yeah, that is correct. The next question says, which compound is most reactive in hydrochloric acid? Now here, in order to understand which one is most reactive towards hydrochloric acid, you need to react them. Let's just see what happens when they react. So when it reacts with H plus, it gives you a carbocation after removal of H2O, because they would form H2O and then H2O gets released and leaves a positive charge. In this case, it would give you CH3 over here. The positive charge would come over this place. In this case, the positive charge, the OH, H would get formed over here and would get released. So the positive charge would come over this place with the CH3. In the first case, the positive charge would come over the place where this OH was there. Now you could clearly understand, to understand which one is most reactive, the one that gives you more stable product, obviously that is the one that is going to be more reactive. So check out which one gives you more stable product. If it's check this last one that isn't having, I mean, a lot of hyperconjugation. Second last, I mean the second one. Hello Ayush, welcome to the session. Mute YT Gaming, hello, welcome to the session. So here if you'd observe, three hyperconjugations from this side, two hyperconjugations from bottom, two hyperconjugations from top. So total 5, 6, 7 hyperconjugated structures are there in the second one. In the first one, definitely nowhere near. In the last one, definitely not. In this one, not a chance. So you can clearly understand, in the second case, you are definitely having more number of hyperconjugation. Observe that none of these have resonance. So you can clearly understand that what is it that with which you would need to use the things. Okay. Hope you're getting the idea. Once you know that the carbocation is more stable, yeah, do let me know, children. And if you are getting a doubt, talk about it. And if you want to ask something, do let me know that. So as you have already observed that this is where the positive charge develops, the electron density shifts to this place. Once it shifts to this place, you end up getting this OH over here. You may say, sir, where did one of the hydrogen go? It would be taken out by the water molecule that is present in the medium. So ultimately that H plus that initially had initiated the reaction had again generated. Hope you've got this idea. When if you would let me know, it would be helping you more. But yeah, do understand it, do try to solve it yourself as well at your home after the session. So with this, we have covered up some of the topics that you are going to be you may use them to or for your benefit. Also, we have a Telegram channel. If you find asking a question difficult here or not good here, you could let us know by joining this Telegram channel and asking that you need. Also, share it with your friends. Let them know about what we are doing. We are bringing everything for you, for your knowledge to be gained without anything to be given, just by using YouTube. Also, do subscribe, like the channel as well as the videos that we are providing for you. And if you find it useful, you could share it with your friends as well. Okay, children, with that known, I'm expecting that you'll be using whatever I've taught or whatever anybody has taught to use them and to solve some problems and get back to me as that, yeah, this is the problem that I've done. Okay, do let me know where are you getting stuck, where you are getting the answers yourself, either in the comment section or in this Telegram channel. But yeah, do connect and let us know. Take care, children. And yes, I'll again be coming live